Hello, everyone. Thank you for joining us. Today's session is the first in a four-part series about apps on Azure, where we will be discussing some of the most popular Azure Cloud Services together with the various concepts to help you learn and implement them in your cloud applications. In today's session, we will cover Azure Cosmos DB, globally distributed no-SQL databases for modern app development. And through this content, you will learn how to set up Azure Cosmos DB and integrate it in your source code and access the data. My name is Hassam Mohsini. I'm the program manager for Microsoft Reactor in Abu Dhabi. Microsoft Reactors are hubs for founders and developers to meet, learn, and connect to local peers, as well as industry-leading ideas and technology from Microsoft partners and the open source community. It's also the home to the Microsoft for Startups program. With a diverse mix of hands-on workshops, expert panels, and community events, there is something for everyone. So check out our calendar of events on meetup.com and join our upcoming sessions. So again, today's session is part one of 4 parts. So I highly encourage you to join us for the other 3 sessions. And throughout this journey, we will be joined by our speaker, Daniel Kay. Daniel is a software engineer who's passionate about Microsoft technologies, awarded with the Microsoft Most Valuable Professional Award, and he's actively sharing knowledge about Microsoft Azure, IoT, Universal Windows Platform, and DevSecOps. He's a course author on Pluralsight and a regular speaker at national and international conferences. He has a technical blog, which is linked on Meetup, and it's at techmindfactory.com. I'm going to send you this link also on the Q&A tab. And you can connect with him on LinkedIn and Twitter. Also, the links are available for you on the Meetup registration page, and I'm also going to drop them again in the Q&A tab. So during the session, you can ask us as many questions as you want. Use the Q&A tab. I will also be sharing some resources that, like the links I mentioned now, and some more Learn modules on Microsoft Learn. So for you to continue the journey and to have something to do after today's session. There will also be some code resources that Daniel had, and I would also share this GitHub repo with you. So one thing I would like to mention before I hand over the mic to Daniel is that you can adjust the playback setting on your screen. So the session is recorded and you can come back to it and you'll find it on YouTube as well as on the landing page created for the series. But during today's session, you can find this small icon towards the bottom right end of your screen, and you will find a way to adjust the playback setting. So make sure you are selecting the highest quality to enjoy the best experience in today's session. Since we will be coding and doing different stuff, this will be the best way to do it. So Daniel, I think that's all for me now. I would like to hand over to you, Daniel, to start today's session. Let me know if you're ready.
Yes, hello, I'm ready. Let me turn on my camera. I had some echo. I thought it's on your side, but it was on my side. So a little surprise, but let me, yeah.
No worries, it's perfect now. I can hear you perfectly.
Okay, so I will turn on my camera and we can start. So let me do it right now. Yeah. Do you see me?
Yes.
Okay,
everyone
great.
can see you. Sent you live. Great. You can start the screen sharing.
Thank you so much. Yeah, thank you so much for the introduction, Hussam. Hello, everyone. I'm super excited. I'm really grateful that I can join Microsoft Reactor Abu Dhabi once again to present some sessions. And today, specifically, I would like to talk about integration with Azure Cosmos DB and storage account. And as Hussam mentioned, this will be the first part of the series called Apps on Azure. And specifically during those sessions, I will focus on the app development. So those sessions are are mostly for developers, but also for everyone who would like to learn more about building applications on Azure Cloud and how to integrate different services to create reliable. So let me show you my screen and presenter mode. So just a short introduction, Husam already introduced me. So my name is Daniel. I work as a principal software engineer at Predica, one of the companies located in Poland. I'm also Microsoft MVP. And I got also my technical blog called techmindfactory.com, so I encourage you to visit it. If you would like to connect with me or you have any other questions after those sessions, just ping me on Twitter or just invite me on the LinkedIn. So I'm really happy to connect. So that's my connection details. So yeah, that session is not about me, it's about Azure and building apps on the Azure Cloud. So let me start with the solution architecture we are going to talk about during our series, I would say. So this is the solution architecture of a fake car rental company called Cars Island. And in this solution, as you can see, there are many different Azure services used. And just to clarify, this solution was built, it's like a fake car rental company. I will show you this solution once I close the PowerPoint. But the goal is just to have a website where customers can see the different cars that are available for rent. They can reserve those cars. They can send an email and connect with the staff working in the Cars Island car company. So as you can see, I use many different services here. And specifically today, we will talk about Azure Cosmos DB and Azure Storage account. So the first part of this session will be dedicated for Azure Cosmos DB. And I hope that you will find it really interesting and helpful for you. I tried to focus on the most important parts when it comes to the app development on Azure. And in the second part of our meeting, we are going to talk about Azure Storage account and Azure Blob Storage account, to be more specific, to show you how to store the files, how to upload files, how to work with Azure SDKs, to make sure that you can easily integrate those services into your application solutions. So first of all, let me start with the Azure Cosmos DB. As I mentioned before, in this Cars Island solution, Azure Cosmos DB was used to store data about the cars and about images, which I will show you. And Azure Cosmos DB is fully managed no-SQL database available in the Azure Cloud to build modern applications. And of course, it provides high availability. As you can see, there is also automatic geo replication and multiple regions, which I will describe. And as you can see on this screen on the right side on the presentation, there are multiple APIs available at the top of the Cosmos DB. And today we are going to talk about document DB and specifically about SQL API. So we can use this SQL API to write queries, for instance, to get the data from our database. And when it comes to the structure of the documents, we will use the JSON format and we can easily extend the model. When it comes to the Azure Cosmos DB, I tried to collect some important facts about Cosmos DB. And first of all, there is always a question about the pricing and about the cost, etc. So what I can say, good news are that we can use Azure Cosmos DB with the free tier. So if you have Azure subscription and you have never used a free tier for Azure Cosmos DB, that's for you. You will get 400 request units and 5 GB of storage for free. We will discuss request units later in this presentation, but you can use it for free. You can just test it, use it for free, and see whether it's for you or not. Maybe you would like to use some other databases available in the Azure Cloud. Now, when it comes to the Azure Cosmos DB, during the account creation, there are 2 types available to select: production and non-production. And the main difference is that with the production mode, we can enable geo-replication, and we also can enable multiple regions, which I will describe in a minute. And now there is also an important question about production apps. And if you plan to run your solution in the production environment, you should definitely think about Geo Replication and in general about the multiple reads and writes regions. And this is something what is connected with high availability and disaster recovery, because when we think about our applications, it's not only about the development side. So of course we need an SDK, we have to integrate with the service inside our solution, etc. But we have to also think about what will happen when one region, for instance, is not available. So will the application work in the future when one region is unavailable? So those are really important questions. And I think that even if we as our developers, we are more focused on the development side, we have to also think about such important aspects like high availability and disaster recovery. Today, I will use the new Azure Cosmos Db Sdk, which is called Azure Cosmos. It's available in preview. And it was, I would say, it was redefined just to stick to the best practices when it comes to the Azure SDK, some best patterns. So in general, I will focus on this one. So I will show you that during the demo. When it comes to the request units and the cost, I mentioned that in the Azure Cosmos DB, there is something what is called request unit. Yeah. So when we make operations against database, each operation costs something, and this is the request unit. On the right side, there is this small picture. I hope that you can see it. We have memory, CPU, some other resources. So Azure Cosmos DB, of course, underneath uses some infrastructure. And now, if we need to query more data, of course, more power, more CPU, more memory is required to process this request. So in the end, the request unit is something what we can use to calculate the cost of our operations in the Azure Cosmos DB. So as I mentioned, request units are an abstraction of system resources like CPU or memory required to perform the operations. And now to make operations against our Cosmos DB database, we need to provision enough throughput. Yeah, so enough request units. And you can ask, okay, Daniel, so those request units, can we extend them, how to plan them, etc.? Of course, you can. I will not focus on this part specifically during our session, but there is a great documentation. We will share the links after the session, but there is a great documentation which you can use to calculate the costs. There is also some information displayed in the Azure Portal, which I will show you. But the main idea behind the request unit is just to have a clear information about the cost. So how many request units do I need to perform the operations on the database? And now, when talking about those different queries or setting partition keys that we will use today during the session, everything is important aspect. Because if you, for instance, wrongly assign the partition key, which we will describe soon, the cost will be higher because probably there will be more request units required to process this operation. The next important fact is that Azure Cosmos DB can be provisioned using I would say free available ways for now. So the first one is provision throughput, so manual. So in this case, you can just say that my application needs 400 request units. Yeah, and this is enough for my application. There is no high load, and this will be enough. So you can set it either in the Azure Portal or using the Azure Cosmos DB Sdk. And then, of course, if there is more power required, I would say, you can then, of course, manually update this throughput in the Azure Portal or using SDK. The second option is serverless. So you don't actually provision any throughputs. You are just charged for the operations that you execute on the database side. Yeah, so in this case, it's exactly like with the Azure functions. You do not pay for the Azure function itself. You pay for the resources when the Azure function is executed. And the third mode Autoscale. This is something I would say quite new when it comes to the public available mode. With Autoscale, you can automatically and instantly scale the amount of the throughput in the Azure Cosmos DB. Yeah, so in this case, you can say, for instance, that the maximum request unit level will be 4,000 request units per second. But if any container is not in use, then those request units will be decreased to 10% of this maximum level. So if we set the maximum request units level to 400, when there is no use on the database, it will just stay at the 400 request units level. So this is something interesting available in the Azure Cosmos DB. It's definitely worth trying, because if you cannot make sure what will be the load of your database, maybe it's good to just set the maximum request level and this autoscale to make sure that if there will be higher load, your Cosmos DB will scale out. Let's see it in action. That's about the presentation. So as I mentioned before, on my GitHub, let's first start with the solution. On my GitHub, in the Cars Island on Azure repository, you will find the source code that we are going to discuss today. So you can go, the link will be also provided. It's called Cars Island on Azure Cloud. So the source code is available on my GitHub. And also important now is the fact that on my techmindfactory.com blog, you can find the series about this application, this solution. So I describe different Azure components, not only the Cosmos DB and Azure Storage account that we are going to discuss today, but also some other integrations. So I really encourage you to visit the GitHub and techmindfactory.com blog. So now let's get back to the Azure Portal. As you can see in the Azure Portal, I've already created Azure Cosmos DB together with some other resources in the resource group. But let's try to, let me show you. Let's try to create a new Azure Cosmos DB database. So if I try to find for the Azure Cosmos DB, here is the service and the tab where we can provide some details. Yeah. So of course I can provide the name of the Azure Cosmos DB. I can select the API. So this is something what I mentioned. Today we are going to focus on the core SQL API. So we can use the SQL queries to integrate with Azure Cosmos DB. But there are some other APIs available, like for instance Gremlin, which is used to create graph database. Of course, we have to set the location, and this is also something important, because if your application will run in the United States, probably this is the preferred region, or if in Europe, maybe West Europe, for instance, in this case, so you can check the list and set up the location. And as you can see, we have this provisioned throughput and serverless. This is something what I mentioned before. Let's say that for now we would like to use provisioned throughput, so manual. And as you can see below, there is this information that Azure Cosmos DB is available with the free tier. You have 400 request units and 5 GB of storage for free. And you can also decide whether you want to apply this discount or not. But please remember that this can be only applied if you do not have any other Cosmos DB databases in your subscription, which are already in use with a free tier. And there is account type, I also mentioned. Yeah, do you remember? So this can be non-production and production. For geo-redundancy and multi-region writes, those options are disabled for non-production, but if you switch to the production, you will see that both options are enabled. And of course, we can provide some details once we decide in which region we would like to use our Cosmos DB, and also whether to use it in production mode or not. Once it's created, let me show you quickly, because I want to stick to the session time. Once it's created, you have full access to it, yeah, using Azure Portal. And what is important here, we have this Data Explorer, which I can open right now. And for the Cars Island database, as you can see here, I have 3 containers: car reservation, and inquiry. And let me show you the car container. And here, as you can see, I have some records. And on the right side, you can also see that this is the car, the information about the car model. We have unique ID of the car, we have brand, model, price per day, and also image URL that is pointing to the Azure Blob Storage, which I will discuss later in this session. So there are multiple cars, as you can see. And as you can see also, this structure is JSON, so it's document database. Of course, I can extend the schema here. I can add additional fields and I can do it without any problems. But there is also this information about the scale, as you can see here. So if I click the scale, I can change the throughput, or I can change it to Autoscale, as I mentioned before. So you can do it here directly in the Azure Portal. And now, when it comes to the Geo Replication also, there is this tab, Replicate Data Globally, and let me show you something. We on the right side, there is this information configure regions, multi-region rights. So let me start with the multiple regions. So by default, if you create the Azure Cosmos DB account in the non-production mode, you will have it in only one region, in one Azure region. So in my case, it was West Europe. But if you go to this Replicate Data Globally tab, you can switch the mode and you can enable Geo Replication. And if you enable Geo Replication, you can add more read regions. And what it means is the fact that, let me show you, here, if I select other region, so in my case, it's West Europe, but also please note that I have an additional region, which is called North Europe, and it's here, yeah, I selected it. So I can add more regions here to my account, as you can see, yeah, and it means that the data will be geo-replicated to those regions. And now, when there will be a failure in the primary region, which is West Europe, Azure Cosmos DB will automatically point out to the second region, which is available on this list. So if there is a failure in the West Europe, Azure Cosmos DB will automatically push all the requests to the North Europe region. And now, let me discard those changes for now. So I have two regions. I have my primary region, which is right region, West Europe, and I have my read region, which is North Europe. Yeah, so this is my backup. And also what I can do if I add more regions, so let's add UAE North here. Oh, I will have to save it, so it will take some time. So I will show you on those two regions. I can switch to the automatic failover tab, and I can enable automatic failover. And what does it mean? If I have more regions for regions like North Europe, UAE North, West United States, etc., if I will have 3 regions there, I can enable the automatic failover. So just to summarize, when there will be a failure in the primary mode, in the primary region, which is West Europe, then Cosmos DB will try to read data from the North Europe. And under North Europe, I could have another region. So if this North Europe is not available, then Cosmos DB will try to get data from the second region, third region, and from the last region that I added before on the tab. Yeah. So this is automatic failover. And of course, if we add more regions on this list, we can also drag and drop and say that, for instance, the first region should be United States, for instance, and the second should be North Europe. So you can manually change those here in the settings. So now if I get back to this tab, there is also this configure multiple region rights mode. And if I enable it, you can see that right now I have multiple right regions. And let me discuss this just a little bit, because I think that this can generate confusion. If you create Azure Cosmos DB in the non-production mode, as I mentioned before, there will be only one read-write region. Yeah, I selected West Europe for my region during the Azure Cosmos DB creation, and all the reads and all the writes will be from this West Europe region. Then I can enable Geo Replication, and I can add the second read region. Yeah, so then, if there will be a disaster in the first primary region, which was West Europe, then the data will be retrieved from the second region from the list. But still, all the writes will be done to this primary West Europe region. So if you want to enable writing the data to multiple regions, you have to enable this mode in the Azure Portal. Once you do it, as you can see, the view changed, and now I have two read regions enabled and two write regions enabled. And of course, when it comes to the application, you do not have to apply anything. This is something what is automatically done by the Cosmos DB. Of course, using the Azure Cosmos Db Sdk, you can say which region is primary, which is secondary. We can manipulate that with the code. But basically, the most important information is available here in the Azure Portal. So now, if I discard those changes for now and get back to the source code, let me show you the sample application. So this is the Cars Island application. As you can see, there is a list of available cars that are available for rent. And this data, like brand, model, pricing per day, location, and image, this data is pulled from the Azure Cosmos DB. So if I get back to the Azure Portal and I will go to the Data Explorer, I showed you that in the Cars Island database, there is cars container. And here I have those different cars like BMW, Audi, etc. Yeah, so those cars are displayed in this web application. And now this application is integrated with the web API. So this is the Swagger page of this web API. And as you can see here, there is this endpoint called API/car/all. And this endpoint will return all available cars in the car rental company. And now, when it comes to the data retrieval, let me open the solution in the Visual Studio. This is the API project. So first of all, what is really important to mention, let me show you. As you can see in the Cars Island infrastructure project, I have this Azure.Cosmos NuGet package in the preview. So this is the latest one. And with this NuGet package, I will be able to integrate with Azure Cosmos DB. So how it is done? In the API project, under core dependency injection folder, there is a data service collection extensions class. And what's happening here? Let me enlarge the code to make sure that we understand the process. We want to integrate with Azure Cosmos DB, and this is why we have to use this NuGet package I showed you. So Azure.Cosmos. And now, when it comes to the integration in the source code, we need a Cosmos client instance. So this is the basic instance that we will use to communicate with the Azure Cosmos DB. As you can see here in the API project, let me just do it like this. In the API project, I'm creating Cosmos client instance with the connection string that is pulled from the app settings file. So here in the Cosmos DB settings section, you can see that I have connection string, I have database name, names of the containers and partition keys. So this configuration is pulled and then is passed to the Cosmos client. And then using Cosmos client, we can create database if it does not already exist. So that's a great method. You can create the database using the source code. And if the database is already available in the Azure Cloud, in the Azure Cosmos DB, we can try to create containers. Of course, under condition that they are not already created. And as you saw in the Azure Portal, I've already added 3 containers here: car reservation, and inquiry. So that is why they will be not created. So here is this method, database create container if not exist async. And here in this method, I have to pass the name of the container and also the partition key. And at the end, I can also pass the throughput. So this is something what we discussed before. So I set it to minimal 400 for this container, and I'm trying to create every container using the code. So as you can see, I'm creating the car container, I'm creating inquiry container and car reservation container. And once the initial setup is created, I can return this Azure Cosmos client. And this Azure Cosmos client is registered in the ASP.NET Core dependency injection container as singleton. And there is a recommendation from Azure SDK team to use all those classes like Cosmos client or other classes available in the different Azure SDKs. There is a recommendation to use them as singleton. And why? Because underneath there is some configuration and implementation done by the Azure Cosmos DB team and SDK team to share those HTTP connections. So that is why it's recommended to use the singleton. So once I register this Cosmos client in the dependency injection, so this is in the ASP.NET Core project, because this is the API project, what I can do then, I have this Cosmos DB data repository. And inside this class, as you can see, I have this Cosmos client instance. It's injected in the constructor. So you can see here that I'm injecting this client that was registered in the dependency injection container. And then, of course, this Cosmos DB data repository is generic, as you can see. It extends the interface called iData repository like this. And there are some basic methods like add async, get async, update async, delete, or get all async. Yeah. And it's generic, but every entity has to derive from this abstract class. So base entity has one property, its ID. So this is the unique ID of the entity in the Azure Cosmos DB. And now if I scroll down, you will notice that there are some different operations like add async. You can see that here I'm getting the reference to the container using getContainer method, which is declared below in this class. So here there is a client get database. I'm getting the reference to the database. Then I can use database.getContainer. I have to pass the name of the container. And then I can return this container so I can use it in the add async method. So here I got this container reference. Then I can use create item async. I can pass the new entity, like a new car, for instance, and then I can create it using this create item async method. And of course, there is some logging added. So I really encourage you to visit my GitHub and go through the source code. And if you will have any questions, just ask them either after the session or later. I really encourage you, because there are some important details. Yeah, I don't want to go through each method because we have a small amount of time. But if you scroll down, you will notice that there are those different methods implemented, like delete async. Again, I'm getting the reference to the container. I'm using delete item async, and I have to pass the partition key value. Yeah, so this unique ID. And there is also get async method, update async, so and get all async. So to get all the items in the Cosmos DB, and everything is done asynchronously. So that's also important. In this new Azure SDK, Azure Cosmos DB SDK, there is async pageable implemented here, and we can use this await pattern for each, so we can iterate asynchronously through the items on the database. So now we can, of course, extend this Cosmos DB data repository. So for instance, I can create car repository class. I can extend Cosmos DB data repository, and I can say that this repository is for the type car. And then I have to only pass the name of the container for the configuration. Yeah, so this is the name of the container. It's used in the base class to get the reference to the right container. But all the methods are implemented in the Cosmos DB data repository. And now if you open the controllers, so here, let me close it, and here we have car controller. As you can see, I have this iData repository, which is using car type. And using this car repository, what I can do, I can invoke car repository get all async. So get all the cars. And if I open get all async, you will notice that it's from the iData repository interface. So finally, I can get all the cars, I can display them. So in the end, on the web application page, you will have this nice list with all the details about available cars and about the image, of course. And now there can be a question, what about the image of the car? Yeah, so you can see that image also is displayed. And I showed you that in the database, the image URL property contains the link to the Azure Cosmos, to the Azure Storage account blob. So if I copy this, you can see that it's publicly available. Yeah, this is one of the car available in the Cars Island. So now, how to upload those images? So then we have to get back to the presentation and discuss Azure Storage account just a little bit. But before that, one thing, please just go through the source code available on my GitHub. You can open the API project. In the data service collection extensions, you can see the registration of the Cosmos client. In the infrastructure project, there are repositories that are using Cosmos DB data repository, which is generic. And finally, in one of the controllers, like car controller, you can see how to use those repositories. So I really encourage you to do it. So now the question is, so where to store those images, those cars images, and how to display them? So if we get back to the presentation, the second service, which is available in the Azure Cloud, the second service is called Azure Storage Account. And to be more specific, Blob Storage. So Blob Storage is, this is the storage in the Azure Cloud. I would say that this is the very first service that was available in the Azure Cloud, and it's optimized for storing massive amounts of unstructured data. So that's the perfect place, for instance, for storing our cars images or documents that we would like to share using the browser or make it available for download. And in this specific scenario, Microsoft recommends to use general purpose version 2 account for most scenarios. So we can use this kind of storage account to keep the files, to create queues, table storages, etc. So below you can see that today we are talking about Azure Blob Storage, but if you create Azure Storage account in the Azure Cloud, you will also have access to the queue storage. So you can create a queues for load leveling in your application. There is also a table storage, so you can add a simple key value pairs in the table in the Azure Storage. And there is also file storage, which you can use, for instance, to synchronize the files that are stored on premises. So you can create a file share, for instance. But today we will focus on the Azure Blob Storage. So this is the best way to store images, to make them available for our applications, and also to make it possible to upload the files and also to reduce the cost. So there are some also important facts about Azure Storage Account. And this is something what I really want to discuss briefly, but discuss the data redundancy and high availability. And this is exactly the same like for the Azure Cosmos DB. There are some variants. So the very basic setup for Azure Storage Account is locally redundant storage. So this is the low-cost redundancy strategy. So once we have the data uploaded to our Azure Storage, it's replicated synchronously 3 times within a single physical location in the primary region. Yeah, so it can be West Europe. There is only one physical location, and it's synchronized 3 times within a single physical location. And this is the cheapest way to store our files. But if there will be any disaster or something will happen with our storage account, we are lost. So I really do not recommend using local redundant storage when you want for your production apps. It's good for testing. The second option available in the Azure Storage account is zone redundant storage. So in this case, we still have one Azure region where our Azure Storage account is provisioned, but in this region there are multiple zones. So in the single region, we can have availability zones, and the data is synchronized among those availability zones in this primary region. And for the production applications to provide high availability and disaster recovery, I would recommend to use either Geo-Redundant Storage or Geo-Zone Redundant Storage. So with Geo-Redundant Storage, the data is copied synchronously 3 times in a primary region, and then the same data is copied asynchronously to the secondary region. So in this case, I can have West Europe and have my storage account in the West Europe region, and then I can have my storage account in the North Europe, and then there will be asynchronous replication of the data from the West Europe to North Europe. The Geo-Zone Redundant Storage, that's something what is really recommended for high availability and maximum durability. The data is copied across 3 Azure availability zones in the primary region, then is copied asynchronously to the secondary region. And for read access to data in the secondary region, we can enable read access Geo-Zone Redundant Storage. So it means that we can copy the data to the second region, and then we can also access this data in the second region. So let me show you using this slide. So this is the locally redundant storage. As you can see, there is a primary region, there is only one data center, and our data is copied 3 times within this single locally redundant storage. If this region becomes unavailable, that's our problem. Application will be not available. There is also zone redundant storage. So as you can see in the primary region, we have those 3 zones, zone 1, zone 2, zone 3. And the data is copied between those 3 zones. This is something better, but still, if there will be a region outage, we are lost. So then there is this geo-redundant storage, as I mentioned before. So we have 2 regions, the primary region where we have our data, but this data is geo-replicated to the secondary region. And in this case, if there will be a failure in the primary region, Microsoft will automatically switch the connection to use the storage account in the secondary region. So in this geo-redundant storage here, we do not decide from which region we would like to read the data. This is done automatically. Here with the Geo-Zone Redundant Storage, this is something exactly like before, but in the primary region we have 3 zones. The data is copied between those 3 zones. Then data is geo-replicated to the second region. And we can also enable this read access Geo-Zone Redundant Storage. So in this case, we can automatically connect to the second region and get the data when there is a primary region outage. And now I would like to show you this in the action. So if I get back to the Azure Portal, let me do it quickly here. Again, in the resource group for Cars Island, I have this storage account created. And exactly as before, let me click Add button on the resource group. And here in the search box, we can type storage account, click Create button. And again, here we can provide the name of the storage account. We can provide the location. So this is something, if I set to North Europe, the primary region I mentioned before will be North Europe. And account kind is storage version 2. General purpose, and this is broadly recommended by Microsoft for most of the scenarios. And below you have this replication tab, and those options I mentioned before. The cheapest option, locally redundant storage, then zone redundant storage, and something what we should aim for the production applications is from the Geo-Redundant Storage until to read access GeoZone redundant storage account. So yeah, so those are the options here. Once you select them, you can click next. There are some other tabs related with networking, data protection also, so we can enable soft delete for the blobs. So if someone will delete a file on the blob, we will have a backup for it. And generally, once we have everything set up, we can click create button. But as I mentioned before, I've already created Azure Storage account. And this is my Azure Storage account. Here I have this containers tab. And please look that I have this car images container and inquiry files. Cars images, this is the place where I store the images of the cars. So again, those cars here. And those are the images. And now each image, if I click the image, each image has a unique URL. So I can copy this one. And if I go to the browser again, wait, let me do it like this. You will see that the car is displayed. Yeah, so I can provide this anonymous access to the blobs. And you can ask how to do it, yeah, how to make those blobs available, those files available for the external world. If you click the container, so here a car images container, for instance, there is this button called change access level. If you click it, you have three options. Private, so no access will be provided to those files. There will be private. There is blob, so there is anonymous read access for blobs, so for the files inside the container. And also there is a container, so you can gain anonymous read access for containers and blobs, so you can see what containers are also created on the storage account. But in this case, the blob is enough. And as I mentioned, each image has the unique URL. Yeah, so I can click it. You can see that there is this URL tab. So now if I get back to the Azure Cosmos DB, here, as I mentioned before, I just copied those URLs for the cars, and I inserted them in the image URL. So this is this property which is responsible for storing the location to the image, which is stored on the Azure Blob Storage. So of course, you can either populate those image URLs manually, or you can just have application that will be in charge of assigning the image to the model in the Cosmos DB. But in general, image URL property contains the location of the image. And now there is also one more thing. There is another container called inquiry files. So this is the place where I would like to store the files that are uploaded by the customers. So if I get back to the application, let me show you, there is this contact tab. And here I can type the message title, so car reservation, let's say, the message content, so hi, I have a question. We can provide some sample email. And we can choose the file. So here I have this sample document. Let me show you that first. This is the sample PDF, like really basic PDF file. I can upload it and click send. But before I do it, let me get back to the container in Azure Cloud for the storage account. And let me delete the existing file. So as you can see, there is no files. And now, if I get back to the application and click send, hopefully there is information. Thank you, we have received your inquiry and we will respond as soon as possible. And if I get back to the Azure Portal and I will click refresh, now you can see that this document is successfully uploaded to the Blob Storage. And also I can download it, I can open it, and this is exactly the same document. So now how it is done. Let me open the API again, because this is the most important part of the configuration. In the API project, again, here, we have some configuration, but first we have to start with the NuGet package. So to integrate with Azure Storage account, with Azure Blobs, we have to use this package, azure.storage.blobs. And this is the package that will enable us to integrate with Azure Blob Storage. And for instance, we can implement file upload like I did in this solution. So now, if I open the API project, again, the core dependency injection, here I have this storage service collection extensions class. And here, exactly like in the previous case with the Azure Cosmos DB, I want to register Blob Service Client, which is provided in the NuGet package I mentioned. I want to register it as a singleton, but first I have to provide the connection string. Where is it? It's located in the app settings. Yeah, so there is Blob Storage settings section in my app settings file. We have this container name, inquiry files, there is connection string, account name, and key. So in this case, we use connection string. And once we register this Blob Service Client, we can register also Blob Storage Service class, which I wrote. So let me show you that. This class can be is located in the infrastructure project, and under services, you will find folder called storage, and there is a Blob Storage Service class. And what's happening in this class? As you can see, again, Blob Service Client is injected by dependency injection available in the ASP.NET Core. And I can use this Blob Service Client to integrate and to communicate with the Azure Blob Storage. So what's happening there? I have a different methods. Let me show you iBlob Storage Service interface. There are different methods I defined. I would like to download blob if it exists. I would like to upload the blob, delete, check whether the blob exists, get blob URL, or generate a shared access signature for the container. Yeah, so there are different methods, but in general, in each method, I'm using Blob Service Client instance. So let me show you, for instance, this method available for the upload. So what I did here on this page. What I have here, we have to pass the stream to the file that we uploaded to the API. I will show you the controller in a minute, but we have the stream and we have the blob name. And now what we have to do, we have to get the reference to the container again in the blob storage. So below there is get blob container method. As you can see here, I'm using Blob Service Client, get blob container client method. And here I have to pass the name of the container, which is inquiry. And if the container does not exist, I will create one using create if not exist async method provided by the Azure SDK for blob storage. And now, once I have the container reference, I can get the blob by the name. So I'm creating a reference to the blob. So the name of the blob will be the name of the file that I would like to upload. So think about the blob, it's just a file that you will upload to the Azure Blob Storage. And once I have this blob reference, on the blob, I'm using upload async method, and I have to pass the stream to the file. And once the file is uploaded, I can return absolute URI, so the address to this specific file. And how the stream is passed to this upload blob async method, let me show you quickly. In the API project, there is a controller called inquiry controller. And here, as you can see, I have iBlob storage service. So exactly the same blob storage service I showed you here. Yeah, with all methods, and this service is using Blob Service Client provided by Azure SDK. If I scroll down, there is this method called add new inquiry async. And here we can, as you can see, there is this from form attribute. And what we have here in the customer inquiry DTO, there is this title, content, customer contact email, but also iForm file. This is the interface provided by ASP.NET Core. So you will find it in the framework libraries. And now, if we pass the attachment, so it's not null, what we do here, we setting the file name. So let me put it like this. We have a file name here. We creating a new file stream, yeah. And then what we have to do, we have to copy the content of the file. We have to copy the stream to the, we have to copy the attachment stream to the stream that we will pass to the upload blob async method here. Yeah. So we have this customer.attachment, this iForm file, and it provides method called copy to async. So we can copy this existing stream to the new stream, which is file stream, and we will pass this file stream to the upload blob async method. And this method, as you can see, has two parameters, stream and also blob name. So now, once I pass this parameter, you can just upload it to the blob storage using this blob storage service. And finally, you will find out that your file is located in the Azure Portal. It has unique URL, and also it's not publicly available because in this case, as you can see, the access level is private. So you cannot access those files from the browser, from any source. It's just not allowed for the anonymous access, like images for cars. So yeah, so basically, when it comes to the integration, I really encourage you to check my Cars Island repository on GitHub, because there you will find many interesting details about this integration. I encourage you to go through the Blob Storage service implementation in the project, and also for the data, Cosmos Db data repository, which is also located in the same project, because here in this project you will find out how to integrate with Azure Blob Storage and how to integrate with the Azure Cosmos DB to build your high available applications on the Azure cloud. So once again, as I mentioned, the Cars Island is available on GitHub. I really encourage you to visit this repository. And now I think that we can go through the questions if there are any, because yeah, basically that's from my side. I'm really happy to discuss any issues or questions you may have. So let me get back to the presentation. Okay. So
Hi, Daniel. I lost you for a second. Okay. So yeah, we got some questions there in the Q&A tab. If you can go over them and clarify these for the members.
Yeah, of course. But you can hear me now, yeah?
Yeah, it was a problem on my end. The community was able to hear you, but I was switching between the headphone and I think I lost you.
Yeah, so yeah, of course. So thank you. So let me go through the questions. The first question I can see: when extend the structure of an item, will that automatically apply to all other items? And the answer is no. So if you extend the model on the item, you can extend a single item in your collection. So this is about the no-SQL database. I would say this is what's behind the no-SQL database, which is Azure Cosmos DB in this case. So you can manipulate the model, you can change the model without any consequences. And of course, when I'm saying without any consequences, it's not like that, because as you saw in my application, for instance, I have this car model and this repository created, so I have to stick to some model consistency. But when it comes to the document DB, which is used here, you can extend this model, but no, it will not be populated on other entities. So it's your responsibility to make sure that when you extend the model, you do it reasonably. Yeah. So you are aware that there will be no issues on the application side, and application can still read this model and adjust to the changes. So that's the first thing. And the second question here, so just to wrap up the first question and answer, I hope that my answer is okay, is fine for you. If you have any other questions, please ask. But yeah, just to make it short, it will be not automatically applied to all other items. So you have to remember about this structure. When use Cosmos DB why use Cosmos DB instead of Azure SQL database? And that's a very good question. So first of all, we have to talk about the scenario and about the solution where we would like to use the database. It doesn't matter which kind of database. First of all, we have to talk about requirements and the kind of solution that we are going to use. And let me put an example. For example, if we want to build a solution where we know that we will have like a consistent structure of the data, we would like to, for instance, store information about the, we would like to store the information about the updates in the system. Let's say that there are some different operations made by users, but there is a consistent data structure. So in this case, probably we would like to have a SQL database, and we would like to have those different relations between the data and entities. But when we talk about the other scenario, can be where the data can be changed dynamically, and the data can be really large, and we would like to also react on the changes. So let me put an example. If we for instance, have a system where IoT devices are used, and there can be many different parameters used, like temperature, humidity, etc. And those parameters can dynamically change, and they have to be updated really quickly. We probably should think about the Azure Cosmos DB in this case. So from my perspective, I recommend using Azure Cosmos DB for the scenarios where you know that your model can be updated frequently. So you know that it's not constant. That's the first thing. The second thing is that you want to react on the events, because with Azure Cosmos DB, there is something what is called change feed. So when the record is inserted or updated in the Azure Cosmos DB, you can, for instance, call the Azure function. So you can build event-driven solutions with the Azure Cosmos DB. So that's the better scenario. And the SQL database is more for the structural relational data model, where you know that you have different entities, there are relations between them, and that's better idea to use Azure SQL database, where you know that model will not be updated so frequently, and you have some clear connections and relationships between the entities. So that's really important. So I would say that Cosmos DB is more for the event-driven solutions. It's more for the solutions where the data model can be changed frequently. For solutions where we would like to provide Geo Replication, high availability, and we would like to build modern apps, because in the end, I can say that Azure Cosmos DB has some, I would say, nice features like this change feed I mentioned, that can be really helpful. That, for instance, we would like to send some update when there is a new record inserted in the database. Yeah, so we can easily integrate Azure Function, use change feed on the Cosmos DB, and then send those updates. So that's my answer here. I hope it will be helpful for you. Is it possible to have a container without an existing repository class? Example, if you wanted to create the container on the go. Yeah, of course. You can have no containers in the Azure Cosmos DB, and you can create them once the application is launched. So there are two ways. You can create them manually in the Azure Portal. You can create them through the Azure SDK. Yeah, so it's really flexible. Is multi-region really needs as the costs are 3 times higher and won't that affect performance? Geo Replication and automatic failover is enough. So let me once again write this. Is multi-region really need as the costs are? Yeah, but that's a very good question. So I can say no. So for most of the scenarios, it will be fine to use one write region and to have geo replication for the read regions. So I would say that write regions are really for the critical scenarios where you would like to have like a full consistency and you would like to make sure that your data is right among different regions. So for most of the scenarios, I can fully agree that there can be one write region and you can have a second read region, and that should be enough, because please remember that still Azure Cosmos DB is the managed database in the cloud. So there will be no situation like 3 regions will be not available. So yeah, I can say that for most scenarios, the second read region will be enough without the second write region. So 1 write region and 2 read regions like this, because it's costful. Yeah. So yeah, so the second question, for the change feed, is there a cost associated with it? For example, if the Azure function has to go through and update millions of documents, how does that affect the UIs? Is that expensive, or is that less costly than manual using an update? Yeah, that's a very good question. So so when it comes to the change feed, there is no cost with change feed itself. So this is just about events. So we can just call the Azure function and pass the new entity. But the cost will be when we want to connect back to the database and pull some more data. So in this case, there will be additional cost and there will be additional request units required. So yeah, definitely I can say that if you want to make some operations when there is an Azure function triggered using change feed, you will pay for that. But in general, change feed is something it's like for events, so you will not pay for the change feed. And yeah, so that's generally it. Sorry, there is one more thing. There is a dedicated container created for the change feed. So there, when it comes to the updates on this container, it's called lease container, and with this there are some request units connected. So I can say that the cost about the change feed is really low. But when you want to communicate with your database back once the Azure function is triggered to pull more data or make some updates, yes, there will be additional cost. So some thought has to be given on workload needs as collections and partitions need to be planned. Exactly. So that's very good sentence here. Exactly. When it comes to the partition keys and collections, it's really important to focus on the data structure, because if you wrongly assign partition keys, there will be higher cost on the database side, because we will have to go through each partition and find the specific data. So it's really important also to spend some time on the data structure. So yeah, I think that's it. I do not see any other questions.
Thank you, Daniel, for today's session, and it was very informative. I would highly encourage everyone from the community members to spend a minute on the Reactor survey, giving us some feedback on the sessions and the topics they would love to see at the Reactor. And as we mentioned earlier, this session is recorded and will be available on YouTube soon. Make sure that you register for all the upcoming sessions that are posted on Meetup. I'm just gonna drop the link to the upcoming part 2 in the session, and maybe Daniel want to highlight some of what we will be covering in that session.
Yeah. So first of all, thank you so much for joining today's session. In the next session, we will talk about user authentication and Microsoft Identity Platform, and specifically, we are going to focus on securing our applications using Azure AD and Azure AD B2C. So that's the next session topic.
Awesome. So yeah, the link is there on the Q&A tab. I also shared with everyone a couple of Learn modules that Daniel has recommended for you to continue the journey, learning about the Cosmos DB and Azure Storage accounts as well. So you can also continue the journey after this session. Make sure you check out also Daniel's GitHub repo for the code and resources. And we will see you next week for part 2 of this series. Hope you stay safe and have a wonderful rest of the day. Thank you everyone for joining us, and thank you Daniel again, and we'll see you next week.
Thank you so much, everyone. Thank you, Husam. See you next week. Bye-bye.